Welcome to the Walton Pi. Today I'm going to be sharing with you a really cool technique to factor polynomials called synthetic division. So, to do this, I have constructed the following nice polynomial to be able to do something with. So let's look at this polynomial. We are trying to figure out how on earth can I factor this. So synthetic division allows us to be able to go through and factor this through a guess and check method. It works really well if you are trying to also divide polynomials, but what we're going to be doing is we're going to be trying to just make guesses of things that we think are factors, and if so, it gives us a way of being able to pull out what that factor would do if we were to factor it all the way out completely. So the first thing that I would recommend doing is to first see if there's anything that we can clearly pull out, like maybe everything has an x in it, or maybe everything is even, or maybe everything's divisible by 5. Do things like that to simplify as much as you can before you jump into synthetic division. So the first thing I notice is that everything here is divisible by 2. So I would see, can I just pull out a 2 from everything? And when I do so, I get a 2 times 90x to the 5th minus, let's see, what is that divided by 2? That's 758 divided by 2, that is 29, x to the 4th, plus 918x cubed, plus 3249 x squared, minus 3348x, minus, let's see, 9720 divided by 2. Let's see, 96 divided by 2, that's 48. So this is minus 4860. And now the next thing I would do is there another number that I can pull out from everything? We can't pull out another 2, but 729, that's a power of 3. So let's see if we can pull out a 3 from everything. So 90, yes. 729, yes. 918, yes. 3249, also yes. In fact, all of these are divisible by 3. In fact, we can do a little bit better than that. Everything here is divisible by 9. Now, if you're not sure the trick for that, if you add up all the digits and it's divisible by 9, then the number is divisible by 9. And if you add up all the digits and it's divisible by 3, then the number is divisible by 3. That only works for 3 and 9 though, so don't think that that works for everything. But if we go through and look at something like 3348, for example, 3 plus 3, that's 6, plus 4 is 10, plus 8 is 18. 18 is divisible by 9, so 3,348 is divisible by 9. So we can actually pull an 18 out from everything. So we get 18 times, pulling a 9 out from everything else gives us a 10x to the 5th. 729 divided by 9 is 81. X to the 4th plus 102 x cubed plus, let's see, what is that divided by 9? Let me just do this in a calculator real quick. That is 361 x squared minus, let's see, 3348 divided by 9, that's 372. And then minus 4860 divided by 9, that is 540. Okay, so now that we have done this, at this point I'm not seeing anything else that we can do, because 10 is not divisible by 3, and 81 is only divisible by 3s, so that means we can't pull out any more numbers. So that means somehow the rest of this is going to have to factor out. So the next thing to do is to look at the last number, so 540, and to start listing some common factors. So for example, we got 1, 540, we got 2 with 270, we got 3 with 180, and then there's a few others, but we'll do those in a bit. Now what we're going to be doing is we're going to be looking to see which of these do I want to try and factor out first. And the interesting thing is, well, not interesting, but important to remember is we could use the plus or minus versions of each of these. So what I would recommend doing is start with some of the smaller numbers and try and see if either of those work. So let's start with plus or minus 1. So here's how we set up synthetic division, or at least how I set up synthetic division. I say I'm going to try and factor out a 1 piece. So this is representing an x minus 1 term. So if I'm trying to pull out a 1, I'm now going to list all the coefficients in the order that they came. So it's a 10x to the 5th minus 81x to the 4th, a plus 102x cubed, a plus 361x squared, a minus 372, and then a minus 540. And now what I'm going to do is leave space for a line. Now here's the process of synthetic division. The first number you just drag straight down. Okay? That's fairly straightforward. The next step is the piece that gets a little bit tricky. We are going to move this here, but multiply by what our specific number is. So it's 10 times 1, so that's going to give us 10, and then we are going to go down by adding. So when we move these down, we add those. So negative 81 plus 10 is a minus 71, multiplied by 1 is still minus 71. But then when we move them down and add, 102 minus 71, that's 31. Let's see, moving that up here, we get just 31 there. 361 plus 31, that becomes 392. Moving it up, 392, that becomes 20. Moving it up becomes 20 minus 520. Now, what does this mean? Well, it means that if we divided our polynomial by x minus 1, what we would get is, so polynomial divided by x minus 1 is equal to 10x to the 4th minus 71x cubed plus 31x squared plus 392x plus 20 minus 520 over x minus 1s. Which is useful when we're dividing things out, but what we wanted was we wanted it to factor completely, meaning that this term would have been a 0, which it wasn't, which means that x minus 1 is not a factor, which is a little bit discouraging, but the fact that we had a few things canceling out means that maybe we're close. I don't know. The thing with synthetic division is it's basically just guess and check repeatedly until you actually find something that works. So now let's go ahead and try something else. Let's now, instead of looking at 1, let's look at minus 1. Because remember, we have to check both the positives and the negative versions of each of these numbers. So, if we are looking at minus 1, that is now x minus negative 1. So now let's go through this entire process. So bring the 10 down, that becomes 10. Multiplied by minus 1 becomes a minus 10. So that's a negative 91. Oh, and then when we here, remember we multiply by negative 1. So that becomes a positive 91. So it becomes a 193, a minus 193 when we multiply it up by minus 1. Adding those two together, let's see, what do we get? That's 361 minus 193. Let's see, that is 168. Alright, so we bring that up. That's a minus 168. And those two add to give a minus 540. And then when we multiply by negative 1, that becomes a positive 540 as to give us 0. And what we have successfully done is we have now pulled out an x plus 1, which means that this polynomial that we have up there is now equal to 18 times x plus 1 times this stuff, 10x to the 4th minus 91x cubed plus 191x squared plus 168x minus 540. And there we go. We were able to pull it out one term out, which means that we have successfully reduced this polynomial down a little bit. So now let's try the same thing, but now on this new polynomial, and we're going to be trying some other things. So we already tried negative 1, and we tried plus 1. Let's try something else. Let's try 2 now. So now, let's see what happens if we pull out, oops, change the pen size. Okay, So now let's look at what happens if we pull out x minus 2, which in other words is the 0 of that one is a 2. So let's go through. We got 10 minus 91. We got 191. We got 100. And we have a minus 540. So here, let's go through step by step again. So bring the first term down. That becomes 10. Times 2 becomes 20. That's a minus 71 times 2 is minus 142. Let's see, 191 minus 142, that is 49. Times 2 becomes 98. Let's see, 168 plus 98, that's 266. Times 2 is 532, which is negative 8. Oh, I was like, I wonder why everything's not working out, because when I constructed it, that was an answer. So it's because I wrote something down wrong. So let's fix all of that. Okay, minus 1 plus 193, so that means that's a 193 there. Now let's go through and finish this properly. So it's minus 71 times 2, that's minus 142, which means that we then get 51 times 2 is 102. That gives us 270 times 2 is 540, which goes to 0, which means that we can now factor out that term too. So it's 18 times x plus 1 times x minus 2 times 10x cubed minus 71x squared plus 51x plus 270. And then we're just going to keep going through this process over and over and over until we've gotten it down to as far as we can go with this. Now, we can do this with things that are not only integers. We can do this with fractions. It's just a lot trickier when you're doing stuff with fractions. And so hopefully we will be able to reduce this down to something that is going to be able to be factored, because we're currently at a cubic. So if we can find just one more solution that we can pull out from everything, we're going to be golden. Now, how are we going to be able to do that? Well, let's just try and pull out some other things that divide 270. So here, 270, we got 1 and 270. Whoops. We got, and let's see, 270 divided by 2, that's 135. We got 3 and 90. It's not divisible by 4, it's divisible by 5 and 54. And then hopefully those will work. Now we've already looked at 1 plus or minus 1s. We've already looked at the plus 2. Let's maybe look at minus 2 and see what we get. So for x plus 2, which is the minus 2 term, we got 10 minus 71, 51, 270. We got 10 times negative 2 is minus 20, so that's minus 91 times negative 2 is 182. That becomes 233 times negative 2 is definitely not going to work out. So that means negative 2 doesn't work. Now the nice thing is once you eliminate a number, you never have to check it again. However, we might technically need to go back through and check x plus 1 and x minus 2 again, because they might show up more than once. But let's just continue and try some other things first. So now let's look at maybe x plus 3. See what that does. X plus 3, that's a minus 3. So 10 times minus 3 is minus 30, so that's a minus 101. 303, that's 354 times negative 3, definitely not going to work. Let's try positive 3, so that's x minus 3. Let's see what that one does. So 10 times 3 is 30. That becomes a minus 41, minus 123. Let's see, what is that? That is negative 72 times 3 is 200, negative 216, which is not 0, so positive 3 didn't work. Let's try, oh, we already tried negative 3, so let's try the 5s. So let's try x minus 5. So we got x minus 5, so that's a plus 5 right there. So we got 10 times 5, that's 50. That becomes a minus 21 times 5 is minus 105. 105 minus 51, that's 54, so that's a negative 54. Times 5 is negative 270, which goes to 0. So we just factored out one more term. So we got 18 times x minus 1, or x plus 1, x minus 2, x minus 5, and what we're left with is a 10x squared minus 21x minus 54. And then this, we can either be clever with how we factor it, or we can use the quadratic formula, and we end up being able to finish factoring this as x plus 1, x minus 2, x minus 5, 2x plus 3, and 5x minus 18. And there we go. That is how this was factored, and we were able to do so using synthetic division. I hope this was helpful and that you enjoy synthetic division as much as I do. I hope you have a great rest of your day, and good luck with the rest of your math.